Welcome. The title of today's notes is Systems of Linear Equations in 3 Variables. So yesterday we looked at 2 equations in 2 variables and tried to find the ordered pair that makes both equations true. Today we're going to take a look at 3 equations in 3 variables and try to find what is called the ordered triple that makes each equation true. So we're going to have an x, a y, and a z. And this relates nicely to what is called a 3-dimensional coordinate system, essentially coordinate space, in contrast with what we've seen before with a coordinate plane. So on a coordinate plane, every point on that plane can be located through an ordered pair. The x value gives you the horizontal distance from the origin, and the y value gives you the vertical distance from the origin. Perfect. 2 dimensions on the coordinate plane. In this case, what we're going to take a look at very briefly is coordinate space, the 3 dimensions. So one part of the ordered triple will tell us basically the length aspect of it, and so I would characterize that as the x-axis, and sort of the how far forward and how far backward we go. I would categorize the y-axis is the width, essentially, and so this would be the how far to the right, and by the way, right positive, left negative. And I should have said this before, on the x-axis, front would be positive, back would be negative. And then now the third dimension here, the z-axis, I suppose would be the height aspect of it. So kind of the length, the width, and the height, the x, the y, and the z. And so this would tell you how far from the origin to go either up or down, up positive and down negative. So you can see just a little picture on your paper there. I pasted in a 3-dimensional coordinate system. I actually have one handy if you want to take a look at an actual 3-dimensional coordinate system, so we can take a look at it in a little more detail if you would like. But essentially, here's what I have. This is the x-axis running right through here. And so front positive, back negative. And then the y-axis here, sort of the width component again, right positive, left negative. And then the z-axis, of course, everybody, would be the height aspect to it, and up positive and down negative. So you kind of see that piece. So if I wanted to find a point in coordinate space, I would, from the order triple, I would figure out how far to go front or back. So here's sort of the x piece. You can kind of follow that lead. The y would tell you how far to go horizontally there, right or left. So in this case, going to the right. And then the z component tells you how far to go up or down, and so you'd go up. And based on the order triple, x, y, and z, you would be able to find any point in coordinate space. So I'll just read a couple things that are on the paper there, pretty much have alluded to it. But every point in 3-dimensional space is denoted with an ordered triple, and so that's, guys, what we're going to solve for in this lesson, x, y, and z. And as we all know, a linear equation in 2 variables produces a line on the coordinate plane. Well, as it says on your paper here, a linear equation in 3 variables represents a plane instead of a line, so a plane in coordinate space. And so this is the type of equation we're going to see today, linear in nature, so really all the variables to the first power. And if I was to plot the infinite number of points in coordinate space that make that equation true, it would form a plane on in coordinate space. And so what we're going to take a look at, just from a geometry standpoint, is 3 linear equations in 3 variables, 3 planes intersecting, and there are a variety of ways that 3 planes can intersect, but the primary way that we'll look at is that 3 planes intersect at a single point. And that single point can be denoted with that order triple, x, y, and z. So we're going to go through the same methods that we've gone through before, substitution and elimination. Obviously, just gets a little harder now, and we have to be a little more careful with our arithmetic. So let's see what it says on your paper there. The objective, and we talked about this on the last notes worksheet, you want to break the system down. So I would argue you want to break the system down from 3 equations in 3 variables down to 2 equations in 2 variables. Once we can do that, then we're pretty much in our comfort zone. So it says then we can use strategies from yesterday to solve for the variables one at a time. So we're going to try to break it down from 3 by 3 to 2 by 2. Once we get to 2 by 2, we're going to try to break it down to 1 by 1. And once we get to 1 by 1, we can solve for one, then use that to solve for another, and then use that to solve for another. And so that's what we're going to do. We'll try both methods out. Again, essentially you're just going to pick your poison at the end here. In terms of substitution versus elimination, you'll just have to decide what you like. So let's do a couple together, and again, at some point, you might gravitate towards one as opposed to the other. So let's see. It says, let's try elimination for this system of equations. Pick a variable to eliminate, and it says perform the mathematics twice with two equations. I'll show you exactly what I mean by that. So let's take a look at the numbers in front of the x's and decide if we want to eliminate the x's. The numbers in front of the y's, see if we want to eliminate the y's, and the z's. I would argue, and again, this is more subjective than anything else here, that we could probably work with the x's and eliminate them by dealing with these two equations. If you kind of look at this piece, I have a negative 3x here. I could probably pretty easily get a 3x right above it. So I can eliminate the x's in these two equations. And then kind of tying together 1 and 3, same idea. I have a negative 8x down here. Well, if I go ahead and somehow manage a positive 8x right up here, which shouldn't be too hard, then I can eliminate the x's that way as well. So what we're going to do, as it says, we're going to do it twice over with two equations. So here's how I'm going to run it. And again, if you decide to take a different path, that's perfectly fine. I'm going to go ahead and especially the first time, I'm going to really write out every step for you. And I'm going to be extra careful with my arithmetic. You do the same. But basically, going to get this piece right here. So I'm going to eliminate the x's in those two equations. And then everybody, I'm going to pair it up one more time. As I said, the first and the third. It sort of looks like they can go together pretty nicely, and I can eliminate the x's there. You do have to choose one variable. So I can't say something along the lines of, ooh, I'll eliminate x here, but then maybe eliminate y here or something. Choose one variable to eliminate, and then pair it up 2 times over. So if it's okay with you, I'm going to do this. I'm going to go ahead and multiply that top equation by 3. And again, I'm going to be a little careful here. I'm going to rewrite this. I could theoretically just multiply it in and add simultaneously, but I do want you to see every single step here. And so you decide for yourself what looks good and what you're able to shortcut a little bit. Just again, err on the side of caution there. Writing every step I think is helpful. So got that piece. And this is definitely a situation where you make one little mistake. Unfortunately, it's all going to go haywire. So I have a 9y, 22z, and then equals 7. And I'm going to just make sure I have everything legitimate on my paper. Yep, that's good. So before I start going into new steps, I want to make sure everything is correct. All right, so here we have one equation and 2 variables by eliminating the x's, and that's good. One equation, 2 variables, it's a start. Now, everyone, I'm going to multiply this top equation by 8 and refocus and do the same thing. So 8x and 16y and 40z equals 8. Again, be very, very careful with it. Multiply every single term by it. I've had a lot of students over the years copy the problem down wrong. I've had a lot of students over the years just forget a negative. Just lots of little things can add up here to just one mistake making all the difference. So again, I'm going to make sure I have everything correct here, but it looks like it's ready. I'm going to go ahead and add the system at this point, and I get 21y, 52z, and looks like 19 there. Okay, and notice when we did that, we did elimination, and now I have, as you can see, 2 equations, 2 variables. And that hopefully will be our comfort zone here. So this goes now back to yesterday's lesson. And first step, done. It's looking good. Now let's see if we can continue the process. So I have that piece and this piece. 21y, 52z, and then equals 19. And so we have to decide which variable we're going to deal with. Neither one is that great. But I'm thinking the y's as opposed to the z's would be better here. If you can kind of think of multiples of these 2 numbers, I've got one in mind here that I think will work. 9 times 7 happens to be 63, everyone. And 21 times 3 happens to be 63. So I think 63 is a good multiple here. So again, we're going to be super careful with it. But let's see what we can do. I'm going to multiply that top equation by that. I'm going to do this one probably by -7, just the way I see it. And as a result, I'm going to do that bottom one by +3. So I should get a -63y on top and a +63y on the bottom. So let's play it out, everyone. I have this right here. I'm seeing this right here, I believe, 154z. Yikes. This should hopefully work out in the end. And n equals -49. Take a look at that piece, because I'm going to go right into the next one, of course, and multiply that in. And I end up getting a 156z. All right, well, that actually didn't work out too badly, I guess. Ooh, big numbers here, but I think we can play it out. Those 63y's are going to go away. And fortunately, these were fairly close together, so I'm getting a 2z equals 8. And which means, of course, everyone, wow, a third of the problem is done. That's a lot of work for just a third of the answer. Okay, so I do have a z value of 4. Now, I do this myself, just off to the side, kind of thinking about it. It just keeps me grounded on what I need, or what I have, and then what I need from there. So everyone, what you want to do at this stage, of course, is use that 4. Once I know that that 4 represents the z value, you can put it in any place you want where you would solve for the next variable. In this case, I have a feeling we would put it back in for z, maybe right here or something, and solve for the y that's missing right here. So find a place. It doesn't have to be where I put it. I'm going to just do this, 9y, and 22 times 4, and that equals 7. All right, so this would be 9y and 88 equals 7. Again, working through good math here, 7 minus 88 just happens to be -81. And not too bad, all things considered. Could have been worse. Y is -9, and that's looking pretty good. Okay, so 2/3 of the solution set taken care of. Now the only thing to do is use those two numbers to find the third. I kind of go back to my original there. Maybe this top one would do it justice. I don't know. Find a spot where you're comfortable with. If I don't see a great spot and you do, use it, of course. But I would do one last thing. I'm going to come right over here, everybody. I've got some room. And now we have 2 times -9, 5 times 4, and then equals 1. And so let's see what we get here. I have a -18, everybody, right here, and a +20. So it looks like x plus 2 equals 1. And subtract the 2. And there it is. All right, you see how many different calculations you have to do in order to get a successful ordered triple here. So it can be cumbersome. Again, I think just from my experience with working with students on this, it's not the concept, it's the arithmetic. And it's the calculation. And it's every single one of them adding up and being perfect all the way through. That's the trick. All right, I have faith that you can pull it off. Well, let's maybe try one more of these, and then we'll kind of get into the next piece. So again, just let's decide here. Really, I think you can't go wrong on this one. That's what's kind of interesting about this. Let's see. Do we want to do x? Do we want to do y? Do we want to do z? Well, I did x last time, so let's at least, just for argument's sake, let's just pick another letter. I'm kind of liking z. Let's try that. Let's see what happens there. And actually, I see it already. I see some good things happening. So everyone, I'm going to eliminate the z's, if that's all right with you. If you want to go y's on this, hey, more power to you. But I'm going to go ahead and take the first and the second and put it together. And so that would be this piece right here. And I'm also going to take the first and the third and put them together. Again, totally your call on which pairs you set up. But let's see, first and third. Okay. Now, just from what I see on this one, I'm actually going to work on the one on the right first, and you'll see why momentarily. Where we can't escape this piece over here, so just be ready for that. But I just see the z's are ready to go, so I'm more inclined to go ahead and at least do that and see what happens. Let's add the system right away and then go for it. And do you see the good thing that's happening here? So when I add the system together, the z's are going to cancel, but also, and this is helpful I think, the y's cancel too. So right away you end up getting 3x equals 6, which is great because now we are down to one equation and one variable, 3x equals 6, and so x does equal 2 right away. That was relatively fast just by adding those two together. Now here's the only thing with this. It looks like we've shortcut it and we're so thrilled and all this, but here's the only problem. You know, what do we have to do at this point? Well, I can put the x or the 2 back in for x and go from there, but I think regardless, everyone, we're going to still have to do something like this. We're going to still have to work with it because I'm only going to have one variable there, and I'm going to need to find the other two. So long story short, I think I'm going to go ahead and multiply this by 2. And if it's okay with you on this one, I'm going to try to do the 2 steps in one. And if you want to experiment with this, great. If you don't, I would encourage you to rewrite the top equation after being multiplied by 2, rewrite that with the bottom equation, and then do exactly what I'm doing here. But if I multiply that 2 in, 2x and then a negative 4x would give me a negative 2x. And then a 2 times negative 2y, that would be a negative 4y. Negative 4y and 1y is negative 3y. And in this case, let's look at the z's. 2z and negative 2z, that did cancel. So that goes to 0. And then a negative 8 and then plus 1 should be negative 7 there. So when I go ahead and multiply that 2 in and then add the system, I do get this one equation with 2 variables. The good news is, of course, I already know that x is 2. So again, it's that idea of we're breaking equations down. We're breaking the system down as much as possible. This is equivalent to what's up here. This obviously quite a bit more user-friendly. So let's go for it. Now I think we're ready. That x value is 2. And let's just be a little careful with this. I have a negative 4 minus 3y equals negative 7. I'm going to add the 4 to both sides, everybody. And I get negative 3, and y equals 1. Now, I should have done this when we found x, just to, again, orient myself. But the x is 2. I did find that the y value is 1. And then the only thing I'm missing, of course, is the z value. And so, again, it's just you're finding good places to put these numbers and solving accordingly. I'm just going to put it in that top equation up here, just from what I see. But again, if you have a better spot, perfectly fine, of course. So x is 2, y is 1, z is missing. And so let's go find that piece. And so I've got the 2 minus 2 here. And so it looks like that'll just cancel out. And this worked out relatively well. And z is negative 4. And that, everybody, is your order triple. Now again, I didn't say this for example 1, but it does bear saying here, we should check it. You know, if I put 2 and negative 1, 2 positive 1 and negative 4 in, should give us this. 2 positive 1 and negative 4 should give us this. And last one, 2 positive 1 and negative 4 should give us this. So please, you know, I'm not doing you a service here by actually checking those answers, but if you have the time and the inclination, you really should do that. Check them, make sure you've got it right, and then if for some reason it doesn't balance, you know you did something wrong. Okay, well that's elimination there. We're going to try a little substitution in just a sec, and see how this one goes. So it says, let's try substitution with 3 variables and 3 equations. Use the same process as yesterday, but expand it. So here's what I mean by that. Yesterday what we did is, to solve by substitution, we got a variable by itself. And that's exactly what I'm going to do here. So we're going to pick one of the variables. There are 9 to choose from. You know, I see one being maybe a little better than the other 8, but you know, that's just my perspective. I like that top x. Seems like we can get that by itself relatively easy by bringing the 3y and the 3z on over to the other side. And so that's exactly what I'm going to do, everyone. So here's what I have on my paper. I have that x is equal to 3y minus 3z minus 4. That is what x is equivalent to. Now again, it's not necessarily pretty, but it should do the job here. It should sort of meet our objective. So in this case, I circle it, just kind of the habit that I've developed. And if that's x, then it can replace the x here, and it can replace the x here. And you can see how it's a relatively fast way. Now, it's going to get a little ugly here momentarily, but it is a relatively fast way to break a system down from 3 by 3 to 2 by 2. So that's what I'm going to plug in for x, and let's see what happens. Oh, my goodness. So 3y minus 3, oops, I made a mistake there, so let me quickly fix. So 3y minus 3z, that should be, minus 4, and then let's just be extra careful there, plus 3y minus z equals 15. I do it on the bottom, same idea. So 4, and then 3y minus 3, I'm sorry, did it again. That's very interesting. So 3y minus 3z, meant to say. And so let's do that properly for you. Minus 4, and then minus 3y minus z, and then equals 19. So it's really the first step we're talking about, that's substitution. Everyone, what I'm going to ask you to do is take a moment and simplify this. Let's get this down into our y and z terms on the left side equal to the constant on the other side. See if you can manage that. So distribute and combine like terms. So what I did when I did this, I got a 6y and a 3y. So I have a 9y, a negative 6z, and a negative 1z. So minus 7z is what I have. And then I have a negative 8, which will go on over to the other side there. And when I add 8 to the 15, I get 23. So check that out. Make sure you agree with that piece. I'm going to do the same thing here and hope for the best. I have a 12y and a negative 3y down on the bottom, so 9y. Actually, that's nice. I have a negative 12z and a negative 1z, so negative 13z. And then let's see what happens with that constant. I get a negative 16, but I'm going to add that to the other side. And 19 plus 16 do make 35. Again, check your arithmetic there. Make sure it's legitimate. But now, as you can see, 2 equations, 2 variables in a decent form. And let's see if we can manage it. Goodness gracious. I'm going to go ahead and multiply the top by negative 1. I see that as a 9y and a 9y. Let's just change that coefficient on the top. And again, if it's okay with you, I'm going to try to put 2 steps together and consolidate this. If you're uncomfortable doing that, then again, multiply the top equation by negative 1 and rewrite the system, then add. But if I do this correctly here, I got a 7z now and a negative 13z. I'm seeing this as a negative 6z, and then a negative 23 and a 35 make 12. And so I get z is negative 2. All right, great. I'm going to start my ordered pair right over here, everyone. So x, y, and z. That's the good news right there. Now let's go backwards, of course. So we have some good things up on the board there. You find the spot. If you don't like my spot, find a better one for yourself there. If you have z, find a way to get y. I'm just going to throw it in right here where I see it. But again, if you see a different place, no harm at all. So I have a 9y and then minus 13 times negative 2. And that would be equal to 35. Just make sure you keep track of all the numbers when you're recopying an equation. I know it sounds crazy, but make sure you copy it correctly. So let's see what we end up getting here. I get 9y and then plus 26 equals 35. Bring that on over, and we get 9y equals 9, and y equals 1. Okay, 2 down, 1 to go. You know the drill here, everyone. Find a spot. You can do it. And let's see what we have going here. So I'll do it in the top equation, that original. Oh, actually, you know what? I just sort of saw it modified anyway. Just kind of looking at this piece here, you know that x is equal to 3 times y minus 3z and minus 4. So I guess I'll just do it right there. Seems like an easy spot. So 3 times 1 minus 3 times negative 2. And then minus 4, of course. And so it looks like we get 3 plus 6, and then minus 4. I'm seeing this, everybody, and you'll do the arithmetic too for me. I'm seeing that as positive 5. And lo and behold, we have our triple. 5, 1, and -2, I think, is the winner. All right. Again, a lot to go through. There's so much. So I'm sorry for being redundant. Sincerely, I am. But be very, very, very careful with your arithmetic. Every little operation you do. You can see how easy it is to make a mistake. Let's try one more. I think we'll skip the Broadway theater problem on your sheet there. I'll just give an answer for that, and if you want to go through it, you're more than welcome to. So kind of the last one, and I did notice there's an extra credit problem on this one, so I'll read that one, and you can take a look at that at your convenience. So let's go substitution one more time here. Let's see what we want to do. I was just going to say for this one, because I see a couple different options, let's vary it up a little bit. Last time we solved for x, and again, that top x looks like a perfectly legitimate candidate on this one for substitution. I'm going to choose a different one just to vary it up a little. I'm going to go with the middle y. If you decide, hey, Mr. Meyer's crazy, why is he doing that? Find another one. Doesn't matter. So guys, I'm going to go ahead and start the process here. I'm going to bring that, or get that y by itself, bring the 4x over, bring the 2z over. Actually, I kind of like that. That was a good choice. Everything's positive there, and that looks pretty good. So it is up to us. Let's see what we can do on this one. So the circle, and if that's what y is equal to, then it replaces that y right there and this y right there. Just remember, it goes in the other equations, of course. So again, just be very careful with copying it down. So instead of x minus 2y, I'm going to replace that y with my nice expression here. Okay, and I'm going to do the same thing down below, and I get 2x, and here's my 2. That looks great, minus the z, and then equals 10. So it looks like I've substituted correctly there. Now what I should have is 2 equations and only 2 variables there. It looks like I'll be working in x and z as a result. So let's see what happens when I combine some things together. Again, I'd encourage you always just pause the video, see if you can work a step ahead, and then see if what you did is correct. So I'm going to do mine up here. I have a 1x minus 8x from what I see. So a negative 7x. And then I'm just going to be a little careful there. I have a negative 4z and a 1z, so negative 3z. And then I have a negative 2 in terms of units. Bring that over to the other side by adding 2. And negative 4 plus 2 seems to be negative 2 there. All right, that's good. One equation down, one to go. 2x and 8x from right here. Give me 10x. That's nice. Let's take a look. I get a 4z and a negative 1z. Ooh, couldn't have asked for anything better there. There's a 3z on that. And then let's talk about units. Looks like a positive 2. I'm going to bring that over to the other side, of course. 10 minus 2, and now gives us 8. Okay, I like this. This worked out rather well for us. And so in this case, I'm going to add those two together. The 3z's should go away. I get 3x equals 6, and x equals 2. All right, good. There's the beginnings of the order triple. So 2, and then we'll fill in the rest in just a sec there. And let's go and get them. So last stage, find a spot. You know it. Need the x, or I have the x, I should say. Probably need the z now. I like just keeping things positive, just personally. So 10 times the 2 plus 3z, and that equals 8. So if I solve this, 20 plus 3z, and then equals 8. As you can see, guys, just one step at a time. 8 minus 20 should give me that, and z equals negative 4. Okay, so 2 taken care of, and now just the last one, that middle one. Again, it's probably the one good benefit of substitution there. You already know that y in terms of x and z is written right here, so I would just do exactly that piece. Let's put x in here and z in here, and let's solve it. So I have 4 times 2, and then plus 2 times negative 4, and plus the 1. And it looks like I get an 8 and negative 8. These are going to cancel out to 0, plus the 1, and I end up getting 1. And that is it. Outstanding. Now, I don't want to make you feel bad, but if you go back to, I believe, example 2, we actually already solved this system. It is the same system from example 2. If you notice, we did that one by elimination. Here we did it by substitution. And the only reason I selected the same system is so you can see just 2 different methods going at the exact same thing. I don't know if you can recall how we solved that one or how cumbersome it was or how efficient it was, but maybe you can start comparing and contrasting which you like better. Again, I don't have a preference one way or the other. I like them both. Substitution works out fine. Elimination works out fine. It's just whatever you see in terms of the numbers in the system and whatever works for you. Okay, so we've gotten some practice on those 2 pieces. I think we can cross out 5 for now. We're going to do some applications in the near future there, and so we don't have to do that one at this stage. Doing a nice job with this, and just keep at it with the arithmetic. Let me do a quick read-through of the extra credit. If you happen to get this, you can definitely just put it on the next take-home quiz or just show it to me at some point, and I'll be able to give you extra credit for it. So I actually stole this problem, by the way. There's a national public radio show called Car Talk, and on that show they happen to do what's called a puzzler every week. And this just happened to be one of the puzzlers, a long time ago. So here we go. It says you have $100 to buy a combination of 100 dogs, cats, and mice. Dogs cost 15 each, cats cost $1 each, and mice cost 25 cents each. How many of each can you buy? And you have to buy at least 1 of each, so you can't do 100 cats for $100. So you have to spend exactly $100, and you have to buy exactly 100 animals. What's the combination that'll do it? Again, if you pull that off, you let me know. Good one to take a look at. It's kind of a fun one. So you'll see why it's extra credit as you start to set it up a little. All right, well, definitely get some practice on 3x3s, and just careful. Please come up and ask questions on this. And as I mentioned, sometimes it feels like a needle in a haystack trying to find the mistake, but we'll see what we can do. So good luck with this, and as usual, of course, thank you very much for listening.